Okay, so I just wanted to make a little addition to my video on Topos research goals. So I had a couple of other ideas of things that could be done. I suppose the first one could really be called a category theory research goal. Um, Now, the idea basically is that using symbols like for all and there exists and arrows and such, we can get these really succinct symbolic definitions of important things in category theory. So here's an example. A natural number object is an arrow 0 from 1 to n and an arrow s from n to n, such that for all arrows p from 1 to a and arrows f from a to a, we have that there exists a unique arrow u from n to a such that u0 equals p and us equals fu. Now, the idea basically is that what we can do is play around with this. So we can enumerate lots of different kinds of category theory structures in quotes, which have descriptions in terms of lists of symbols of for all there exists unique, and so on. So this actually should be exists unique here. And then we can list them, and then we can see do they actually correspond to something in category theory. Now, this is quite ambitious because it's going to be difficult to interpret if you just make a load of random lists of symbols, but hopefully there'll be a way to systematically determine whether these lists of symbols correspond to uniquely defined things in category theory, and the goal is to find the simplest stuff that's of conceptual use in category theory, because I've not seen anywhere a sort of convincing argument why limits, co-limits, exponential object, sub-object, classifier, and natural number object are the sort of most important devices in category theory. They seem to be the most important things that people use to reason about things like toposes and etc. But I mean, maybe there are other things like that which are very, very simply defined, but have not been found, have not been appreciated. I mean, why it seems like most of those things I've just mentioned are um, just sort of generalizations of things that we already use in mathematics, mostly in set theory. Um, but there ought to be other useful things which are maybe quite different. So some kind of systematic search of the simplest kind of definable category theory gizmos maybe will be very profitable. And I call it NKS style in deference to Stephen Wolfram's A New Kind of Science, which really advocates this approach of, if you have a given system, search through all of the things you can generate with the simplest rules, enumerate them, and see what you get, because usually you get surprising stuff that's useful. So, okay, that's one idea. Another thing, just something I want to look at in the future, is apparently there's a paper by Koch called Universal Projective Geometry via Topos Theory. So that ought to be interesting. But that's an aside. The other idea is I don't think I've seen many people apply category theory to game theory. So there ought to be a way to make a kind of category of games. Okay, so one possibility is it could be like set to the power of m, the category of functors from a monoid m with a free monoid with a generator for every player. So then that we'd have a system. This is more like kind of almost like board game theory. We have all these game states, and then we have arrows as transitions corresponding to the moves of the different players. So, for example, we might have a game like this. But another thing we can do is have this category of functions, and then we can consider games where it's you have basically we can restrict our attention to functions from strategy choices to numerical outputs, and then maybe we can do some category theory on those. And then of course there's also potential games which would correspond with partially ordered sets or something, because you have potential functions there. So yeah, there ought to be a lot of application, a lot of interesting things you can do with that kind of approach, and maybe one can find a topos which one can do some of this kind of research in, and consider things like the products or co-products of games.